Alright, here's 20 and 24 that you asked about. It's a logarithmic equation, so we're going to write each side as one logarithm first. Even before that, I'm going to move this. Let me try to change that. Okay, I'm going to move this 4 and make it an exponent on the 3. So 3 to the 4th is 81. So as I write this side as one logarithm, what I have is the natural log of x goes in the numerator because it comes from a positive log. 81 goes in the denominator because it comes from a negative log, equals the natural log of 1/5 x. Okay, now we can cancel logarithms. Now really x over 81 is the same thing as 1/81st x, then would equal 1/5 x. Subtract 1/5 x from both sides. So you'd have 1/81st x minus 1/5 x equal to 0. And if you do the subtraction, you get negative 76 over 405 x equal to 0. And if you divided both sides by negative 76 over 405, you're going to get x equal to 0. Now we need to check that back in, and when we do, that means right here I would have the natural log of 0, which we can't have. You can only take the log of a positive. So what have we learned here? There's no solution. Okay, that takes care of number 20. And for number 24, part A, how long would it take 5,000 to turn into 18,000 at 3.8% compounded monthly? Notice that I made my n 12 in the formula because we're compounding monthly, so that's 12 times a year. Here's my interest rate, my present value, and my future value. And of course I want to solve this for the t. Which makes this an exponential equation, and I want to get that part isolated first. So I'll divide both sides by 5,000 first to help me with that. 18,000 divided by 5,000 is 3.6 is equal to, if I take 0.038 and divide it by 12 and then add 1 to it, I get approximately 1.003, and then that's going to be raised to the 12t. And now I can take the log of both sides. It doesn't really matter whether you use common logs or natural logs on this problem, so I'm going to just use common logs. So the log of 3.6 would equal, we'll move 12t out in front, times the log of 1.003. And then if I divide by 12 times the log of 1.003, then the t will be by itself. So I need to do that on both sides. Those to cancel and those to cancel, and the t is by itself. And do a little calculator work here. Log of 3.6 divided by parentheses 12 times the log of 1.003 is approximately 35.6. Now that's a little bit different than what your book says. Your book gives the answer as 33.8. And I got 35.6, so that's a considerable difference. The reason why is I rounded here to get the log of 1.003. So if I wouldn't have rounded, my answer was 33.76. So if your answer is slightly different than the books, that might be why, because that threw me off more than I thought it would have. So I probably shouldn't have rounded that number. This number without rounding is 1.0031, and then a bunch of sixes repeating. It's really that number. Okay. Now down here, it says how long would it take if we compounded interest continually. So here's my A is equal to P times E to the R times T. So I just substitute into the PERT formula. Again, we're going to divide by the 5,000 to get that part by itself first. So we're going to get 3.6 again, equal to E to the 0.038 T. And then this time we want to take the natural log of both sides because we've got an E. So the natural log of 3.6 will equal, pull the 0.038 T out in front, and we know that the natural log of E is 1. And now we can divide both sides by 0.038. Get those to cancel. If I take the natural log of 3.6 and divide it by 0.038, I get 33.7 years. So it only gets you there a tenth of a year quicker than it did compounding monthly.